Hello everyone, my name is Trina Malarkey, and this is my flash talk for my poster titled Expanding Performance and Usability for High-Speed and Low-Dose stem scanning. So I'll just start, the outline of this will just be pointing out my key results, and then if you'd like to see the full treatment, please look at my poster later on this afternoon. So just very briefly, when we're looking at a microscope controlled by a Gatan DigiScan, we have the DigiScan take control of the scan, we produce the detector outputs that we're interested in, which feeds back into the DigiScan, which then creates an image from this. But if we're working at low dose stem conditions, we see that what's usually a continuous output from the detector might be like peaks due to individual electrons. So I have a previous work on dealing with this, and how it was done was we used a USB powered oscilloscope to take this signal, pass it to a laptop where we digitize it and then form digital images this way. So this was good for dealing with the artifacts that arose due to these peaks, but it was quite limited because we were limited by the RAM size of the laptop and the streaming speed of the oscilloscope used, and also this didn't run live as a microscope. So one of the key outcomes today was how can we improve on this? So what we've done, instead of streaming to a laptop, we have a field programmable gate array, or this one is a red Fataya. So we outcouple the signal from the detector straight to this. We digitize it in hardware, pass that back into the DigiScan, which sees this digital signal just as another detector signal and natively produces digital images at the microscope, which is very useful. But if this is a signal for low-dose imaging, and if we're talking about low-dose imaging, there's kind of an elephant in the room, which is how do we navigate, focus, and stigmate, etc., when we're using such low doses? So what we've introduced to deal with this is Smart Search, a package in Digital Micrograph. And what one thing is capable of doing is live averaging in the stem, such as you see in the SEM. So here we have a single frame, and here we have a rolling live average of, let's say, the last 10 frames. So we can actually focus and stigmate and navigate and not have to work at a higher dose and then move to a new part of the sample. And furthermore, this actually saves all the frames to a data buffer, and we can rewind to these later on. This is applications in situ stem, or maybe imaging fragile materials if we want to rewind to before some damage happened or a key dynamic event happened. And even then, as we have all this data, by just averaging approximately 50 frames that we wouldn't normally have access to afterwards, we're able to produce quite high signal to noise ratio image of the sample of data that would typically be wasted. So just to summarize, by using a FPGA, which integrates with DigiScan, we can perform digital imaging live at the microscope. We plan to make this a plug-and-play module, and we have a printed circuit board which works with the red Fataya to allow this to happen. By introducing a rolling live average, Smart Search makes navigating at low doses possible, while the data buffer means all data, time, and dose spent at the microscope is useful. And the combination of these two approaches means that not only are we counting every electron, but we're making sure that every electron counts. So with that, I'd just like to thank you for listening. My poster is number 19 in this afternoon's session, so I hope to see you there for any questions you might have.